Hey guys, I wanted to give you this little behind the scenes video because I alluded in the solution video, I alluded to having to use Desmos and figure out a couple of tools to understand that problem a little better. So you can watch this or not, but I thought I'd just show you how I use Desmos and how I use these tools to understand the problem better. Okay, so first things first, I decided to just try to figure out what this function looked like. What did 15a squared minus 4bx ax squared plus 4bx plus 4c look like? So I started by throwing that into Desmos and graphing it. Now, when you use letters like A, B, and C, Desmos is very kind and gives you these 1, 2, 3, A, B, C sliders. So now I can actually start sliding this thing around, and you can see my screen is changing. And essentially giving me an idea of what this parabola looks like. Well, I know that A values they act the way I expect them to. They make my parabola wide or skinny, right? Also, check it out. When A becomes negative, it flips my parabola upside down. I know because the problem said it can't be negative that I've got to live on the other side of 0. So first things first, parabola is always facing up. That's really going to be important to note. All right, so now let's talk about what B and C do. B does this super cool thing, which I wasn't like super aware of, but check it out. Moves up and then kind of down, and then up and then kind of down. So that's kind of cool. It almost looks like the vertex is moving the way in a parabola shape. Like the vertex is moving in a parabola shape. Okay, so then C values. Okay, they just move up and down without really changing a whole lot. That makes sense. I remember that from just shifting functions. Okay, but that still wasn't getting me to where I needed to be. So I thought I'd try to understand what is happening with b squared and 15ac. I mean, the book claims that b squared will always be bigger than 15ac. So I made this little table. I put b squared here, 15ac here. And then I started shifting things around. Okay, right now, notice that b squared is actually smaller than ac, but now it's not. So 2.25 is actually bigger than -3, so it's not always true. And I got really stuck thinking about this. I was like, well, okay, what is forcing b squared to always be less? There must be something else. So I was kind of staring around. I started shifting b. I was like, okay, well, look, b squared is bigger than 15ac. As soon as I moved it over here, b squared became bigger. What is going on? So I was getting a little bit frustrated. So then I was like, all right, well, I haven't done anything with the fact that my parabola has to be greater than or equal to 0. So that's when I introduced this step right here and graphed that. And now I went back to the sliders to play around and figure out what's going on. I started sliding b around again. So far, so good. Huh. And then I started like parting the C in the middle. I was like, what is going on? It's purple everywhere. And when I move A, anytime my parabola was negative, it turned upside down. It started looking like this, and I was like, well, that's kind of weird. So playing with C, and it wasn't until I started to play with all 3 of these sliders that I began to understand the problem better. Whenever that white space shows up, it only happens in the locations where the function is less than 0. And that makes sense because the purple represents where the function is greater than 0 or equal to. So anytime the parabola dips below the x-axis, my table becomes false. Check it out. B squared is bigger than 15ac right now, and I have white space. But if I move the slider to a point where it's all purple, watch what's happening to the values in the table down here. B squared is bigger right up until that purple is all gone. Or sorry, the purple is everywhere. The white space is gone. And now b squared is finally smaller than 15ac. So I was able to put together like, oh, okay, It has to be true because the parabola must be at the x-axis or higher. It has to be equal to 0 or positive. And all of this stuff works as long as I'm under the assumption that the parabola is 0 or higher. Once I figured that out, I was like, oh, okay, so that takes us back to discriminants. That, back to the drawing board here. Whenever a parabola is equal to 0, that means your discriminant is equal to 0. If it's positive up here, no x-intercepts, then this thing has to be negative and cause imaginary numbers to happen. So then I built my two cases with the parabola idea and those pictures. We talked about discriminants and how when you put those two results together, you get what the book was trying to get you to prove. I made this video honestly just to encourage you about persevering through these problems and using tools that are available to you. Desmos is a really powerful tool and got me to a place where I was finally thinking about the problem correctly, and I could go all the way and make my algebra align with what I was understanding graphically about this picture. As mathematicians, as IB learners, the more you kind of develop this perseverance, this interest in the problem, not shying away from it, that's ultimately the goal of being a lifelong learner, is just, being okay with that discomfort and moving into a place where you understand what's going on. Using the tools around you strategically to understand the problem better and get you to a solution space is ultimately the goal. So anyway, I hope that was kind of cool, showing you how someone can use these tools, how I approach using these tools, and use them to inspect a problem and figure out what's going on. Just that authentic kind of problem solving. So anyway, if you watch the video here, thank you. And then I hope you have fun and try this out eventually on your own. See you guys.